All right, guys, welcome to lesson 23. In this one, we're going to go even further talking about properties of logs. So we have our basic properties, which we've already talked about. We have our inverse properties that we've already talked about. But in this lesson, we're going to introduce the idea of product, quotient, and power properties. All right, so with exponents, when you add or when you multiply like bases, you add your exponents. When you divide like bases, you subtract your exponents. And when you raise the power to the power, you multiply. Well, we can translate these to logs and natural logs. So we're going in the other direction. So here, we added exponents because we multiplied like bases. So if we're multiplying here, we can separate that into addition. Same thing here. We can separate it into addition. If we're dividing here, we can separate that into subtraction. Same thing here. If we have a power up here, we can bring it down. So we take that, bring it down. Take the y, bring it down. That's what's going on. All right, so let's put this in play. On your calculators, there are two keys for logs, one for common log, base 10, and one for natural log, base e. If there's a problem you're working with that has a different base, then you can change it based on the formula below. All right, so I can take log base x over log base y. I could also use natural log instead of common log. And so I can do that. So here's the idea. So my calculator can't handle log base 4. So I say log 25 over log of 4. And then you get the same answer. It's a beautiful thing. Now, my calculator can't actually handle that. But depending on your own calculator, maybe it can't. But that doesn't mean you can't do the problem. So like on number 2, I got log base 12 over log base 2. All right? And you don't have to just use log, you can use natural log. So I could say ln of 140 over ln of 5. On 4, I can say ln of 2506 over ln of 7. Again, it's a beautiful thing. All right, we can actually rewrite this using our properties in that box above. Right, what 2 times 3 is 6. So this is actually ln of 2 times 3, which means I can rewrite this as ln of 2 plus ln of 3. All right, so it says to rewrite it in terms of ln 2 and 3. So, and that's what I did. All right, here you have ln of 2 over 3 cubed. All right, and so since this is dividing, I can separate this with subtraction. Ln of 2 minus ln of 3 cubed. All right, but I don't really want that power there, so I'm going to use the power property and bring it down. So this would be ln 2 minus 3 ln 3. And so that is a different way of writing it. I'm going to do the same thing in terms of 3 and 5. So here you have, this would be the same thing as 3 times 25. So this would be log base 3 plus log of 5 squared. And again, I don't want that power there. So that's going to be log base 3 plus 2 log 5. All right. Here on B, we have log of 3 squared over 5 cubed. All right, so I can do that by subtraction. I can say 3 squared minus log of 5 cubed, and then I'll use the power property. So this will be 2 log 3 minus 3 log 5. All right. Now this one says evaluate without a calculator. So what this is saying is let's rewrite the cube as a fractional exponent, or the radical as a exponent, as a fractional exponent. So now this looks like one of our properties that we did in a previous section, where this whole thing is going to go away, and I'm left with that exponent as my answer. So this is simply going to be 1/3. So you can see we didn't need a calculator for this. All right. Here on b, we know that this goes to 1 and this goes to 1. So this is simply 6 minus 2, which is 4. So once again, it may look like we need a calculator, but we didn't. Okay, you can already see from some like 5 and 6, we've already kind of done some of this, but in this next section we're going to focus on expanding, and in the following section we're going to focus on condensing. So depending on what the problem is and what you're trying to do, sometimes it's actually beneficial for you to separate this stuff out and expand it from something simple to something more complex, because maybe you can work with one of the parts that lives inside of it, or maybe it makes more sense to condense things. So starting with number 8, we're going to expand this. So this would be log base 7 of 8 plus log base 7 of 6. Because it's multiplying together, I can separate it with addition. So that's one expansion. Number 9, this would be log base 6 of 12 minus log base 6 of 5. Okay, now 12 is a multiple, 6 is a multiple of 12, but 6 times 6 raised to some power does not give you 12. So I can't do anything with that. All right, number 10. All right, I got log base 2 of 9 to the 1/3. All right, so I'm going to bring the exponent down. So this will be 1/3 log base 2 of 9. All right, and that's all I do there. All right, number 11, I got log base A of R to the 3/5. And so I bring the 3/5 down. I got 3/5 log base A of R. Okay. Now let's really test our skills here. So everything on the top is going to be adding because it's all multiplying, and then everything on the bottom is going to be subtracting. All right. So here's the catch. Let me just work it out. So here we go. We have log base B of R plus log base B of, we know we're going to have to bring that 2 out front, so that should be 2 log B of S plus log base B of T minus log base B of, it should be 3 out front, and then it should be a U, and then minus 5 log base B of V. So even though U and V are on the denominator together, and technically they're multiplied together, you always consider things in terms of the numerator. How does U relate to the numerator? Well, it's in the bottom, so I got to subtract. V is also in the bottom compared to the numerator, so I subtract it as well. So one thing you could think about is this is minus 3 log V of U plus 5 log base B of V. You can think about it that way, where you're subtracting the product and then you distribute the negative. There's 2 different ways of thinking about it, but ultimately what I have here is your answer. Okay. All right, let's do another one. All right, this one we got a root. So let's write the root as a exponential fractional exponent before we go any further. So we got log base A of R cubed S squared over T to the 4th, all raised to the 1 over M. All right. So now this is going to be 1 over M log base A of R cubed. I'm doing this in steps. So that's the first term. Then I got 1/3, 1 over M log base A of S squared minus, because T is in the bottom, 1 over M log base A of T to the 4th. Now, I don't like all those extra exponents, so I'm going to bring them down front. And when they get there, they're going to be multiplied by the 1 over m. So here's what we got. We have 3 over m log a of r plus 2 over m log base a of s minus 4 over m log base a of t. And that is my final answer. All right, so expanding is not necessarily my favorite because I like to make things simple as possible, but it is a useful tool. All right, what about condensing? The thing that I would rather do is, the good thing is you have log base 4 everywhere, and as long as all the logs are the same, then I can only have to write it once. And so you have x. All right, we set up here that because u and v were both in the bottom, it was minus minus. All right, same thing's true here. So you have x, and then you have minus, and then you have plus. All right, so x is definitely on top, but because it's plus z, z is also going to be on top, y is in the bottom. All right, so watch out for that. It can be a little tricky. All right, so let's see. We got, you can do this in a couple steps if you want to, but this is going to be log base b of r to the 4th over s to the 5th. Okay, so you have 1/3 and a 2/3. So let's just go ahead and write this. It's going to take a couple steps to get this right. So we have x to the 1/3, y to the 2/3 over xy. Okay, well, I don't like those exponents, so I'm going to write it as a root. So you got log base a. So if you take a 1/3 out of 1/3, you get 1. If you take a 1/3 out of 2/3, you get 2. So we have, let's see, we have we have x y squared to the 1/3 over xy. And then we can finally say log base a of the cube root of xy squared over x, y. Okay, so this would be my final answer. All right, the last thing we're going to talk about in this section is they tell us that log base 10 of 2 is this decimal. So can we rewrite this in a central way using our properties to expand or contract, or expand or condense, and get log base 2 to show up? Well, that's easy because 4 is 2 squared. So if I rewrite this as log base 10 of 2 squared, and then I take the 2 in the exponent and write it out front, that'd be 2 log base 10 of 2. Now I can replace the log base 10 of 2 with that decimal, and that's going to be 2 times 0.3010, which is going to give me 0.6020. All right. What about 5? 5 doesn't go into 2. 2 doesn't go into 5. All right. You have to think creatively. All right. We have, how can 2 relate to 5? Well, 10 over 2 is 5. So let's write it that way. So we have log base 10 of 10 over 2. And then we can separate that. And this is an example of where expanding this thing, it can actually be helpful. So we have log base 10 of 10 minus log base 10 of 2. Well, we know from our properties that log base 10 of 10 is just 1. And then we know this is what they told us. So that's going to be 0.3010. So 1 minus that is going to give me 0.6990. Okay. All right. So I know that was a lot. Please feel free to rewatch this if you need to. Ask questions if you need to. And I'll see you in the next lesson.